Okay, the next variety of rectangular lamina of size 30 mm by 60 mm. 30 mm by 60 is resting on the ground. Resting on the ground in the sense what? Ground means horizontal, resting on the ground with one of its shorter edges, shorter edge in the sense 30 mm, one of its shorter edges, such that the surface is tilted to give the final top view as a square, such that the surface is tilted to give the final top view as a square. Right. Full stop. Draw the projections of the plate, the projections of the lamina. Draw the projections of the lamina. If the resting edge is 35 degree inclined to VP. If the resting edge is 35 degree inclined to VP. Full stop. Also, find the surface inclination of the lamina with respect to the horizontal plane. Also find the surface inclination of the lamina with respect to the horizontal plane. The top view is a square. Right. Then the given data is the resting edge. It is resting with a shorter edge. Resting on where? Resting on where? Horizontal plane. On horizontal plane. It is resting with a shorter edge. Make a note, hint of this. Resting with shorter edge. Shorter edge in the sense it is 30 mm edge. Right. Resting with shorter edge. Right. Then the resting edge is inclined. That inclination is nothing. Resting edge inclination to VP is nothing but the apparent inclination. Right. So I have an apparent that is inclined to HP or VP. VP apparent inclination will be beta. It is VP apparent inclination is nothing but beta. That is 35 degree. So as I told, okay. So where I have to draw the rectangle, true shape of the rectangle on the horizontal plane or on the vertical plane. Where I have to draw it? Where I have to draw the true shape on the horizontal plane. How you see, and you should not make mistake in drawing the true shape first of all. The true shape has to be drawn on where it is resting. Okay, it is resting on HP. So straight away I can draw the true shape. This is my VP. This is going to be my, above the reference line is my VP. Know that this is VP, this is HP. Right. So I can draw my true shape of the rectangle on HP. It is resting on HP. So HP is below the reference line. I have to draw the rectangle below the reference. And how I have to draw it? So either I can draw it like this, the same thing, same rectangle, the true shape I can draw it like this. Which one is right? Shorter edge is resting on the ground. It's going to be rest on the ground. Right. So if I project this, I will have the shorter edge in the extreme. If I project this, which one I will have in my extreme, in my projection? Longer edges will be in my projection, okay? So which one is going to be right? First one, okay? Because I need a shorter edge to be rested on the horizontal plane, okay? If I have the projection, this one if I have it, once I tilt the front view, okay? The shorter edge will be resting on the ground, okay? So I have to draw my true shape in the first orientation what I have shown. here, you see, the true shape has to be drawn. This is 30 mm, this is 30 mm, and length is 60 mm. Great. So this is my square, true shape of the square. Then you rotate it. So this is A. From the left bottom corner you rotate it A, B, C and D. So this is a top view, right? Now to project this in the first step. Okay, I will get my rotations here in this location. This is going to be my A dash, B dash and C dash, this is D dash. Right. So which corner will be hidden as in the front view? So you have to look at the top view from the bottom. AB is visible, CD is hidden. So CD I can mark it inside C and D corner is hidden in the front view. Now I have to tilt it. Okay, in the second step, in the previous problems, I told you use which inclination? Use which inclination I told in the second step? You have to use the surface inclination. Do you have a surface inclination here? As for this problem concerned, you don't have the surface inclination. So this is an edge inclination. Beta is nothing but the resting edge is inclined. Okay, this beta is resting edge inclination. Surface inclination is missing in this problem. Instead of that, what is given? The top view is a square. Okay, top view is a square. The surface inclination is asked in this problem. The finally it is asked, what is the inclination of the surface? Okay, if the top view is perfect square. So my top view is going to be a square. Okay. So in the second step you will be having a top view. That top view will be tilting, redrawing it to the edge inclination. Right. Now in the problem it is given it is going to be a square. Top view is going to be a square. So how I can get a square here? If I project this, so I can extend the horizontal projector. If it should be a square, this length will be 30 mm as it is. Okay, this will be 30 mm as it is. So the sides of this also it will be 30 mm. Okay. So my top view is, as per the problem, it is given. It is the perfect square. It is going to be a perfect square. Now, how I can find out the surface inclination? Okay, I have to project it. Here I can use a surface inclination as for previous problem concern. But I have to find out the surface inclination here. I know the top view here. So how I can find the surface inclination? I can extend the projectors. I can draw the vertical projectors. Right. I can draw the vertical projection. This is going to be my A. D. Now this is square, you know. So which one I have to keep it on the reference line? Here. Either AD or BC, both are shorter edges. Okay. AD also is a shorter edge, BC also is shorter edge. Anyone I can keep it on the reference line. So I am keeping AD here. So that is A dash, D dash. Then what distance I have to measure? This is the front view distance, length, that is nothing but 60. It is going to be 60, right? So that 60 I can measure it. So from here I have to cut it in which projector? The other projector I have to cut it, right? So the A, that is 60 mm, AD, A to B distance, that is nothing but the 60 mm in the front view, right? So that I have to measure it and I have to cut it on the other locus. So this is going to be my front view. So do you have any clarification in this? The previous problems we had the inclination, surface inclination will be given. You have tilted the front view and you have got the top view, final top view. As for this problem concerned, top view is given, it is a square. So you are asked to find out the inclination of the surface. Right. Now as per this measurement you have taken, that is 60. I had another location of this front view, right? So this is the inclination. This is my B dash, C dash. So this inclination, okay, it is going to be my surface inclination. You have to measure it and you have to rotate it. What is this inclination? This is going to be my surface inclination. Okay, this is theta. You have to measure it. What is the inclination you are getting it? You mark it. Okay, that is the problem of. Okay, then you have to proceed for the third step. What is the third step is going to be? You have to use in the third step, which inclination you have to use? The apparent inclination, it is given 35 degree. So the edge, resting edge here is AD. So that resting edge is 35 degree incline. Now which one I have to tilt it? So this is the top view. This is going to be the resting edge. So that is 35 degree it is inclined. So I can draw a 35 degree line. I can draw a 35 degree line. So this line is 35 degrees. So this is my beta 35 degree. So on this line, 35 degree line, which one I have to mark it? This I have to reproduce it here. Okay, I have to mark AD. AD is going to be my resting shorter edge. So AD I can measure it, mark it here conveniently. 30 AD. This is my A. This is B. Then the same square I have to redraw it here. Okay, that is 30, 30. So I can redraw this square. Right. This is the final top view. Okay. As per the problem, this is going to be my final top view. I can darken this. Right. This is AD. B. This is C. Now you can proceed for the final front view. So final front view, you have to project this. Okay, from the final top view I can extend vertical projectors. Right, I can extend vertical projectors. From the previous front view, I can draw horizontal projectors. Right. Carefully you have to mark the notations. Wherever the corresponding projectors meet, okay, you have to mark the corners in the front view. So A here I have D on the reference line. So A is here, projector A, where it meets A projector, here it is D. So this is going to be my A dash. This is my D dash. Right. Then B is here, B. So this is going to be my B dash. C is here, C to C. This is C dash. Joining this, I have my final front view. Is it clear? Listen, this is a different kind of problem, inclined to both planes. Right? So one surface inclination, instead of giving the surface inclination, the top view appearance will be given. The top view is a square. That you know. You are asked to find out the surface inclination. Okay, it's square it is given. You can use the surface inclination. The second, you can find the surface inclination in the second step. Then in the third step, okay, you use the apparent inclination, right? So apparent inclination to VP is beta, apparent inclination to HP is alpha, right? True inclination to HP is theta, true inclination to VP will be phi, right? Is it clear? You have any clarification in this? Right? Appearing in your first test. So this is extra I'm teaching. Take another problem. Okay. Take another lamina, a circular lamina of diameter, a circular lamina, circle of dia 60 mm is resting with one of its circumference point 1. One of its circumference point 1. It is resting with one of its circumference point. Rotation is 1 on VP. On VP. Okay, it is resting with one of its circumference point 1 on VP. Okay, it is resting on where? As per the problem, it is resting on VP. Right. So with this one, I can draw my true shape of the circle. The surface of the lamina is tilted in such a way that the surface of the lamina is tilted to VP. Is tilted to VP in such a way that is tilted to VP in such a way that the front view is a perfect ellipse. The front view is a perfect ellipse of, so the front view is the front view is an ellipse of sides of major and minor axis. Of major and minor axis is, okay, 60 mm, 30 mm. Major and minor axis is 60 mm, 30 mm. Right. Draw the projections of the lamina. If the surface of the lamina is having an inclination 35 degree to HP, inclination 35, surface inclination here is given. That is HP inclination in the sense it is surface inclination is a true inclination, it is theta. Right, theta is 35 degree. Theta is given, it is 35 degree inclined. Right. Draw the projections, sir. Draw the projections of the lamina. Also find the true inclination of the surface with respect to the vertical plane. Also find the true inclination of the surface with respect to the vertical plane. Surface inclination phi you have to find out. Right. So it is surface inclination to VP is going to be phi. Right. So you see here, as far previous problems concerned, you had one true inclination, one apparent inclination. Here in this problem, you have two true inclinations, two surface inclinations. Right. So how to solve this? Quickly I will do it. Okay, the third step only, how to solve it, I will do it. Okay, to solve it. As you know, okay, where I have to draw the true shape, okay, roughly I am going to draw it. So you have to proceed it. Initially in your drawing sheet, you have to proceed it. So this is my X. Okay, where I have to, this is my VP and HP. Where I have to draw the true shape of the circle. Listen this problem carefully. Okay. VP is, it is resting on VP, so I have to draw the circle on VP. So So the circle diameter, so you know the circle you have to divide it into 12 divisions. This is my, I am giving it numbers, rotating in numbers. Then I can project this, right? Since it is resting, I am drawing the true shape on the vertical plane. Then I can project this. I can have my various corners, right? 1, right? The hidden corners will be this, right? Listen. Then in the second step, it is given the front view is an ellipse. The front view is an ellipse. Instead of giving this surface inclination, see here, listen. The front view here in the second the front view is going to be a perfect ellipse. Our major axis is 60 mm. What is the diameter of the circle? It is 60 mm. Right? The diameter of the circle, you know, you have drawn lamina is 60 mm. You can draw that. You have drawn this to 60 mm. This is diameter 60. Right? Now the front view, I know, as like the previous problem, rectangular problem, the front view is going to be a ellipse of major axis, which is going to be my major axis. The 60 mm is going to be my major axis here. The minor axis is going to be 30. So I can construct a 30 by 60 rectangle here. So this is my 30, 60 and 30 I can construct it. So this is a rectangle. Within this rectangle, I can draw my ellipse. I can get my ellipse. Okay. So just you can project these locations. Right. Right. This is going to be right. I can construct. How to construct? So see, wait. Then I will have an ellipse, perfect ellipse. Here. So I'm going to have a final front view as an ellipse of 60 by 30, right? So for this, to get this perfect ellipse, to what inclination I have to tilt my 35 degrees. You see here, that inclination is not given. You see here, the surface inclination is 35 degree. It is theta. Right. With respect to HP. So here, whatever inclination below the reference line you are going to have, that is going to be what? This is going to be surface inclination anyway. So as for this problem, so whatever inclination you are going to have here, surface inclination, it is going to be phi. So that surface inclination is lost phi. So you know this is a ellipse. I can get the inclination of the surface in the second step. That is nothing but similar to this. Here you have got the theta inclination in the previous problem. Here you should get the phi inclination. Right. So what is this inclination? So I can keep my, it is resting with the circumference point 1. So that 1 I can mark it on the reference line. So what is this distance? I can measure it. That I can cut it on another locus. Right. So here it is going to be my tilted top view. Okay, the first step. So you can mark the various locations here. So this I have projected. Right. This I have projected and I have got the ellipse. So what I can do is, this you know, this projectors in between, that is distance is going to be my minor axis 30. So I can tilt my top view to within this 30 mm length, right? So So whatever inclination it has, it is going to be my inclination of the surface with respect to the vertical plane. This is the phi you are asked to find out. Right? Surface inclination. Right? So you cannot use here theta. Theta is always above the reference line. That is going to be my inclination to HP. Okay. So it is given again the surface inclination. So far we have used. This is your second step. Second one. In the third step, which inclination so far we have used? It is an apparent inclination. But as far this problem concerned, again it is given as an surface inclination. That is phi is given. Now which one I have to tilt it to phi? This one. Right. This is my 1 dash. This is 7 dash. Right. This one I have to tilt it to 35 degree or 35 degree. Okay. If it is an apparent inclination alpha, so straight away I can redraw it. Similar to the last class problem. Now it is not an apparent inclination, it is a true inclination. Again, be careful in this step. You see here, so what you have to do is, okay, so just draw a 35 degree construction line. Okay, it is for this inclination. I am drawing a 35 degree construction line. So this inclination is 35 degree. Okay, this inclination is 35 degree. Listen carefully. This is theta 35 degree. So to redraw this in a orientation, I need an apparent inclination with respect to HP. Okay, apparent inclination is alpha. Right. So what I am going to do, I am going to keep this 1 and 7 on this, So 1 dash, this is, I can measure this. What is this distance? Minor axis. Okay, 30. Okay, 30 mm I can measure it. This is going to be my 7 dash. I can mark it. Now, this inclination is having 35 degree. If it is alpha, I can straight away I can redraw this. Okay, using the previous procedure, right? Circular laminar procedure. You see here, now I have to find out the alpha. Along that angle, I have to redraw this. That is the difference in this problem you have. I have to find out the alpha. How I can find out the alpha? If I have a line, top view, front view length, and if I have a line's true length, how I can find out the alpha? If I have a line's true length and if I have the same line's front view length, how I can have the front view? Okay, the similar straight line problems. If I have a line, so you consider this diameter 1/7 as a line. Okay, consider this diameter 1/7 as a line. Okay, this is nothing but what is this 1/7? Front view length. So what is the true length of this 1/7? 60 mm. The true length of the 1/7 is 60 mm. So what I can do is, from here, okay, this is my front view length. So this is going to be the line's locus. Okay, I'm going to have the line's locus as this. Locus of 7 dash. I have 7 dash already. Now what is the true length? This is nothing but the top view length of this diameter 1/7. The true length of the diameter 1/7 is 60. That 60 I can measure it in my compass. This is the location of 1. I can cut it on this locus, similar to a straight line. Okay. So true length I can measure it and I can cut it on the locus. Okay, where I will have that. I can cut it on the locus. Okay. So this is. Sorry, I have wrongly given. So what is wrong I have done here? First of all, what you have to do in your straight line problem? True inclination will be measured with the true length. True inclination will be measured with the true length. What I have done the mistake here? Instead of having the true length on the true inclination line, I have kept the apparent, the top front view length I have marked. So what I have to mark it actually? 60 mm. On the true inclination line, I have to mark the 60 mm. So what is 60 mm? I can mark it here. So this is the 60 mm. Here I will have my 1 dash and this is my 7 dash. Right. So here I will have my locus. Now is it clear now? Now I have the locus here. 7 similar to mine. So this is nothing but my true length of the diameter. Now what I have to mark on the locus only, I am going to have my final front view also, right? Front view length, you know what is the front view length? As 30. Okay, that 30 you can measure it. I can from one dash, I can cut it on the locus. 30 wherever it cuts on the locus. Okay, wherever it cuts the locus. Okay, that is my front view of the diameter. Okay, this is my 7 dash again. Okay, diameter is 7 dash, right? 7 dash. So this inclination, what is this inclination? Actually, alpha. This inclination is going to be my alpha. So this is important. So now, on which inclination I have to redraw my ellipse? Front view. That alpha inclination I have to redraw it. So I have got a line for an alpha angle that is not given, that you have got it from this one. Okay, along this line, along this 30 degree, this alpha inclined line, I have to mark I have to reproduce this front view. So the reproducing this front view, you know, in the previous problem, you know, the same circular lamina, but reproducing this, you know, so just along 1/7 you mark the projector locations. Okay, that projector location you transfer it, right? That projector location you transfer it, draw perpendicular to that, nothing but drawing the vertical projectors. Okay, in this front view, you can draw perpendicular projectors here. Then I can measure these distances, I can transfer it, okay, immediately I can transfer it. So that is going to be my final front view. So from this I can draw the final top view, you will get it. Final top view you will be getting within this explained, and by projecting the previous software I can get. So one is here, right is here. So I have my final view. So I will have my final top. This is going to be my 1. Here I will have my 7. Right? Is it clear? This is one of the equation, right? See here, this is a difference you have. Here, hexagon is the ellipse is given. Instead of giving the true inclination to the surface inclination to VP, then in the third step it is not given the apparent inclination. Again, true inclination is given. So from the true inclination, you have to find out the apparent inclination. Okay, right? Using straight line concept, you can have an apparent inclination. So along that apparent inclination, I have to reproduce this front view. Okay, the ellipse I have to reproduce. Then you can go for your final top view. Right? So previous 3 problems we have used only one surface inclination, one apparent inclination. As for this problem, we have used only two surface inclination. The second surface inclination, we cannot use it as it is. We have to find the apparent inclination for that. Then along that apparent inclination angle, you have to reproduce the front view or top view. Depends upon the problem. Right? Is it clear? You have any clarification?